Welcome to Trigonometry, mathletes. So we're in chapter 12 now, jumping ahead, and 12.1 or 12-1 is trigonometric functions, so basic trig functions. So trigonometry, just like if you break down the word into its roots, trigon, triangle, right, and metry, the measure, and so we're studying the measurement of triangles or the relationships between the measures of the angles and the sides of a right triangle. So that's what trigonometry is and what we're going to be looking at. So trigonometric ratio, those are there's basically six of them, six basic trig ratios: sine, cosine, tangent, and then the reciprocal functions, which are the reciprocals of those particular ones, which are secant, cosecant, and cotangent. All right, and then and then basically a trigonometric function is just a function using a function that has a trigonometric ratio in it, right? All right, and so let's see. Here are the basic trig functions. So if we're given a triangle here, right? So in this case, it's a right triangle. So we have that right angle there, 90 degrees. And then we have this angle theta, and that's called the reference angle. Okay. And you could have another angle over here that could be the reference angle as well. We could call that beta or alpha. But theta is generally, theta is probably the most common variable in trigonometry. It's kind of like the x, like we use x all the time in algebra, or a lot of the times. And theta is commonly used for an angle in trigonometry. So, and it's a Greek letter, and so it's just something to get used to. If you haven't seen it before, you'll see it a lot now. So, all right. So if you have this reference angle here, then you can label the three sides in relation to that reference angle. So, the hypotenuse is always across from the right angle. Okay, so I always make if you make an arrow with the right angle symbol, that'll point to the hypotenuse. Okay, all right. Then you have opposite, which is opposite of the reference angle. Okay, so that's the opposite side. Then you have the adjacent side. The adjacent side is next to the reference angle, right? So that's the adjacent side. It's right next to the reference angle. All right. So that's opposite, adjacent, and hypotenuse in relation to this particular reference angle here. All right. Now, just to let you know, if you take a triangle, and it could be the same triangle, and you put a reference angle here, you put theta here, then now this becomes opposite, right? Now this becomes adjacent because it's right next to, and then hypotenuse is still across from the right angle. Okay. So you could have a situation where you have the same triangle, but the reference angle shifts to one of the other angles in the right triangle, and then that would change opposite, adjacent, hypotenuse. Okay. Now, real quickly, we know that the sum of the measures of a triangle is 180 degrees, right? The sum of the measures of the angles in a triangle is 180 degrees, and so if this is 90 right here, right, then that means that these two angles have to add up to 90 in order to make 180 degrees, right? So one thing that we know about these angles here, like let's call this one alpha, is we know that alpha plus theta equals 90. And there's a word for that. When two angles add up to 90, they're complementary, right? So they're complementary angles. And if they add up to 90, that means they each have to be less than 90, right? And there's a word for that, which is acute, right? So these two angles in a right triangle, the angles that are not the right angle, are always going to be acute angles that are complementary, that add up to 90. Okay. All right. So anyway, that hopefully a little geometry review for you. Hopefully that all makes sense and is all stuff you've heard before. So, all right. So now let's talk about these ratios. So these six trig functions are ratios of the three sides: opposite, adjacent, and hypotenuse. So each one is a ratio of of two of those sides. Okay, so for example, sine is a ratio of opposite to hypotenuse. Okay, so sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, tangent is opposite over adjacent. Okay, and one way to remember that, and you might have seen this before, is SOHCAHTOA. And I'm not sure why this works, but it just turns out to be easy to remember. But sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right. So SOHCAHTOA, if you can remember that, that's one way to remember your main three trig functions. Okay, and those are definitely the most common, are the sine, cosine, and tangent. Okay, and we'll talk about how to use those in a little bit. But the reason that these are important, or the reason that these are valuable, or and how we can use them, is that if we have a right triangle with some angle theta, then by angle-angle similarity, those triangles have to be similar, right? Any triangle that's a right triangle with a reference angle, with that particular reference angle, has to be similar, in other words, proportional with any other triangle, no matter the size, with the same reference angle and a right angle. Okay, so those triangles are proportional, and so that means that this ratio, no matter how big the triangle is, if it's a right triangle with that angle, then this ratio is always going to be the same. Okay, now, and that's true with cosine and tangent as well. Okay, so that's how trigonometry works. It's kind of a combination of triangle similarity and Pythagorean theorem, and that's how all of these phenomenon happen, where just where we can use these ratios in a lot of different ways to solve different situations where we're trying to find missing sides and missing angles in different triangles. All right, so now the reciprocal trig functions. Okay, so these are the reciprocal trig functions, and they're basically, if you look, they're sine, cosine, tangent, but flipped over, right? So cosecant, instead of opposite over hypotenuse, it's hypotenuse over opposite, right? So cosecant is 1 over sine. It's the reciprocal of sine, right? And conversely, sine is the reciprocal of cosecant. So sine is 1 over cosecant. So these two are reciprocals of one another, right? And you can see that here as well. Okay, and remember, if you put 1 over something, that's the reciprocal, right? Like 1 over 2/3 is the reciprocal of 2/3, which is 3/2 if you divide 1 by 2/3. All right, next, cosine and secant, those are also reciprocals of one another. Cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent, right? So secant and cosine are reciprocals of one another. Secant is 1 over cosine. Cosine is 1 over secant. Okay, and then we have tangent and cotangent. Tangent is opposite over adjacent. Cotangent is adjacent over opposite. Okay, and you can see that they have that same relationship where they're reciprocals of one another. So cotangent is 1 over tangent, and tangent is 1 over cotangent. All right. So those are the basic. Those are the 6 trig functions, and we're going to be using those a lot. And like I said, these are the 3 main trig functions, and those will pretty much do everything you need. But it's good to know what the reciprocal trig functions are, especially when you get to calculus. You'll kind of have some relationships that come up, and it's helpful to know the reciprocal trig functions. All right, and then we'll talk about inverse trig functions a little bit later.